So let me ask you, if you had to give instructions to somebody on how to find the absolute value of x for any x, what would you say? Most of the time when I ask this question of students, they say things like, just take the negative away. But then I would say, well, this is math, we have to be really precise about our instructions. What if there isn't a negative in front of the number? And then you might think, well, fine, then just no matter what, write the positive version of that number. And I guess that's better, but I need really, really specific versions of that. I need something that I can write as a formula, actually. And so here is the kind of description that I like. If x is positive or 0, you don't have to do anything. You just write x. But if x is negative, then you need to take the negative sign away. And that is really, really specific. It gives me two different sets of instructions depending on whether x is negative or non-negative. And so this is how I choose to write the absolute value of x. If x is positive or if x is 0, you just take the bars away. No big deal. But if x is negative, you need that negative sign to disappear. We do that by adding an extra negative. And think about it. The absolute value of negative 5, what is it? Well, I would write negative negative 5. Which is really just positive 5, which you already knew. So, how will I write this function, the absolute value 2x minus 3, as a piecewise defined function, just like I did absolute value of x? We're going to explore this for a couple of minutes by making a table of values. When we plug in the number 2, we get the absolute value of 1, which according to the rules on the previous slide is 1. When we plug in positive 3, we get the absolute value of 3, which is again positive, so I just write 3. And as x gets bigger and bigger, I'm feeling really confident that the pattern's going to stay the same. We're going to be taking the absolute value of a positive number, and then you just write that number. Okay, fine. What happens if we plug in 0? Well, you get the absolute value of negative 3, which is the other case, right? So you're supposed to write positive 3 instead. If I were to plug in negative 1, I get the absolute value of minus 5, which is 5. And the more negative x gets, I get the absolute value of more and more negative numbers. And the rule stays the same. You take that minus sign away, you write the positive version of the number. So something interesting happens between 0 and 2. When we plug in the number 1, what actually happens, even though x is positive, we get the absolute value of minus 1. And so the absolute value rules are take the minus away. And please pay attention to that. X was positive, but we wound up taking the absolute value of a negative number. We had to follow that second set of rules. And if I were to plug in little decimals, 1.1, 1.2, 1.3, notice how I'm always getting the absolute value of a negative number. And so I have to take the minus sign away. When I plug in 1.5 exactly, I actually get the absolute value of 0, which is just 0. And then, if I adventure even further, 1.6, 1.7, I start taking the absolute value of positive numbers. So notice how those x's were positive the whole time, but something really important changed right here at this pivot point. This is exactly where we switched from taking the absolute value of a negative to the absolute value of a positive. So it didn't matter that x was negative or non-negative. What matters, it turns out, is whether 2x minus 3, that entire expression, is negative or non-negative. A second thing to notice is you always calculate 2x minus 3. This is a PEMDAS, or order of operations thing. You always calculate 2x minus 3 before you decide whether or not you're supposed to put a negative sign, or whether or not you're supposed to take the negative away. So here is an example of the general pattern that you can use to decompose absolute value functions as piecewise. One of two things is going to happen. You're either going to write the plain old formula with no absolute value bars, or you're going to put the absolute value bars, you're going to turn the absolute value bars into parentheses and add a negative in front. Always one of those two things. The first thing is going to happen when the stuff in the bars is greater than or equal to 0. And the second thing is going to happen when the stuff in the bars is negative. As a separate step, you can choose to solve the inequalities so that you can have simpler inequalities here. And you could choose, if you like, you could distribute this negative and write this as 3 minus 2x instead. I chose not to, but you have some simplification options if you want. And in general, this is the template. This is the pattern. The absolute value of any kind of math stuff at all, no matter how complicated, is either going to be just that math stuff with no bars, or it's going to be all that math stuff with parentheses and a minus sign. You will do the first thing when the stuff is greater than or equal to 0, and you'll do the second thing when the stuff is less than 0. As a separate step, you can solve the inequalities or simplify your expressions. I'm going to do one final example, and it shows this more complicated case. If you have anything outside of the absolute value bars, it cannot affect your inequalities, and it will not ever have a negative sign applied to it. You're just going to copy it down faithfully in your two formulas. So here's an example. For 4 plus the absolute value of 6 minus 2x, I will get one of two things. Notice how the 4 plus was copied down exactly both times in my formulas, and my bars turned into parentheses, or they turn into parentheses with a minus in front of them. I do my one of two things. When does the first formula apply? When the stuff in the bars is greater than or equal to 0. The second formula applies when the stuff in the bars is less than 0. And yes, it's true, that 4 plus makes no appearance here and does not affect the inequalities at all. It just isn't there. So now I'm done decomposing, and because I like when my formulas are pretty, I choose to simplify. And so I'm going to do 4 different things. I'm going to solve these two inequalities, and I get x less than or equal to 3 and x greater than 3. And I'm going to simplify these expressions. The 4 plus 6 turns into 10, and 4 plus minus 6 turns into negative 2. And don't forget you have to distribute that negative so you get a plus 2x.